So I'm going to label the sides the X and the Y, but on these second triangles, they're labeled incorrectly. This side should be 15, and this side should be 10. It's going to change it just a little bit as you solve those two and set them up, but they were set up incorrectly. So you need the 15 and the 10 to be in those two places. So on the first one, I think some of you realized that the relationship that was going on was that you were multiplying by 2, so some of you were doing it without solving it and setting it up. That's okay, but you do need to know how to do it whenever it's not quite so simple. So I'm just going to set it up just so to make sure that you understand. So I would do 20 over 10 equals, if I were going to find the X one, I would do X over 24, and that would give me 48. So then I would do 20 over 10 again, and if I want to find the Y one, I'm going to do the 52 first, because it's from the same triangle as the 20. And then I would get that Y was 26. Any questions about number 1? All right, number 2. Same process, except this time it's not quite so easy to figure out since it's 8 over 6. So if I were going to find the part that went with 15 that I call X up here, it would be 8 over 6 equals 15 over X. And you end up with a decimal. And then if you do the other one, 8 over 6, and this time if I wanted to find Y, or 10, the side that corresponds with 10, I'm going to call it Y. It would be Y over 10. And this time you get 13.333. Because these are right triangles, when you're finding the area, your base and your height are already given to you, because your base is down here and your height's up here. So when you do area, you're going to do 1/2 times that times that. And then your perimeter is going to be adding all the sides together. So let's look at number 3. If I'm going to do the perimeter on number 3, the perimeter of the big triangle, just adding all those sides, comes out to be 480. And the perimeter of the small triangle, when I add all the sides, 480 is not right, is it? It's 120, sorry. And for the small one, it comes out to be 60. All right. All right, area. Area is 1/2 times base times height. So on the first one, 1/2 times 20 times 48. That's where I was getting my 480 from. And then area on the second one, 1/2 times 10 times 24. Okay, and we're going to use those values in just a second. Go ahead and find the area and perimeter for the other two triangles for number 4. So there's the perimeter and areas for that one. And what we're going to do is we're going to use those values to come up with some things that are true about perimeter and area and proportions. Okay, so number 5 says to find the height of the big triangle and the height of the small triangle and divide them. Okay, so Aaron, what's the height of the big triangle up there at the top on the left? Yep, and what's the height of the small one? Good. So you get 2. Questions about that? All right, instead of going to the right, we're going to go down so we can talk about just that one triangle, and then or those 2 triangles for the first problem, and then we'll come in and we'll do 6, 8, and 10. So, Nate, what was the perimeter of the big triangle? And what was the perimeter for the little one?
60.
Okay. It says to divide it. Here's what we get. We get 2. Interesting. All right. Now we want to take the areas and divide them. So, Zach, what was the area of the big one and the small one?
480 and 120.
Good. And we get 4 when we divide them. Does it look like anything is true about perimeters and areas and the sides? We're going to find out if it's true when we do some more problems, but do you notice anything?
The height and the bottom center.
So like 5 and 7 are the same. If I divide the sides of a triangle and divide their perimeters, I get the same proportion. And that's what we hope is going to happen when we do 6 and 8. We'll check and see if it is. Now from 7 to 9, to get from the 2 to the 4, there's lots of things that could happen. We could add 2, we could multiply by 2, we could square 2, all of those equal 4. So we're going to look at what happens from 8 to 10 to try to figure out what the relationship is, okay? So number 6. Peyton, what's the big and the small triangle that we're going to divide in number 6?
10 and 20.
We're looking at the triangles up above on the right.
Oh.
The heights up and down.
8, 6.
8 and 6. Hey Amelia, when I take the perimeters, what are the perimeters?
36.33 over 27.45.
Okay. When you divide that, you get 1.333. Does it look like our thing about perimeters are true? It does. So when I want to find the perimeter of something, if I know 2 of the sides, I could find the perimeter of the other side using a perimeter relationship as well. Okay, area. Let's talk about the area. Abby Greenway, what'd you get for the areas on 10?
1.777.
Okay, so it's 5.333 over 30,
Sorry.
which is 1.777. Is that what you said? Okay, let's figure out what's going on with the areas. So if I go from 2 to 4, it's not adding 2, because if it was adding 2, then I should be able to add 2 on the perimeter on 8 to get to 10, and that's not happening, right? Okay. Could it be times 2? Well, take 1.333 and multiply by 2 and see if you get 1.77. You don't. Okay. So what if we square it? What if you take 1.333 and then square it? Do you get 1.777? You do. Okay. So the relationship between the sides and the perimeter are the same. But the relationship between the perimeter and the area is that we have to square the sides or square the perimeter to find the area. Okay? So let's look at a problem. Let's look at number 11. We have these 2 triangles over here. And it says the perimeter of the big triangle is approximately 22.8. So it's already telling me what the perimeter is. And it wants me to figure out the perimeter of the small triangle. Notice I can't find all the sides because I don't know one of the sides. Well, I might could since I know the perimeter, but we're going to use what we just found out about this relationship to figure it out. Okay? So the side I know this is 4 and I know this is 2. Okay? So I know that 4 over 2 is a thing. I also know that the relationship between the sides and the perimeter is the same. So the perimeter of the big triangle, we already know, is 22.8. And if I want to find the perimeter of the small triangle, I can make the relationship just like this. And this is easier than working with the sides, because with the sides you would have to find two sides, and then you would have to find the perimeter from there. I think it's easier to do it all in one step. It doesn't matter which way you do it, as long as you can do it and get the answer. So cross multiply and solve, and I think you get 11.4. Okay, let's look at the area. So the area of the big triangle is 18, and it wants the area of the small one. All right. Instead of putting 4 over 2, I'm going to square 4 over 2, because the relationship for the area is the sides squared. So when I square 4, I get 16. When I square 2, I get 4. And then I know that the area of the big triangle is 18, and I'm trying to find the small one, so that's how I can write that relationship. area will be less common than perimeter. Perimeter you might see once in a while, but I don't know if you'll see anything about area, but I wanted to make sure that you had seen something like that. So then you cross multiply and solve. What do you guys get for the area? Last problem. Two triangles ABC and FED are similar. The length of sides ABC are 8, 12, 14.4. Length of the longest side of FED is 21.6. What is the perimeter? Okay. In order for me to find the perimeter of FED, I also need the perimeter of ABC because I have to have that relationship. So what is the perimeter of ABC? How am I going to find it? Add them up. So 8 plus 12 plus 14.4. What do you get?
34.4.
Okay. It tells me that the longest side of FED is 21.6. Why is that helpful? So what am I going to compare that longest side of FED to?
The longest side of 8.
And what is that?
14.4.
Good. 14.4 is the longest side of the other triangle. So those two parts go together, the 14.4 and the 21.6. And then the perimeter of FED I can find by knowing the perimeter of ABC. Okay, so let's set up the relationship. We would have 14.4 over 21.6. The 14.4 is from ABC, so what do I put on top? Okay, 14.4 and 21.6, these are the sides, right?
34.4.
This is ABC and this is FED. So I need the perimeter of ABC on top and then the perimeter of FED on the bottom. Okay? And ABC is 34.4. FED is what I'm looking for, so I'm just going to put a P, or you can put X or whatever letter you want to use. Cross multiply and solve. And I hope you get 51.6.